Good morning, students. Good afternoon, students. In the last class, we discussed about some numericals. Okay, in that I gave one for homework, that is 2.7 in the entire textbook, that is Henry's law. I can say this is how much? Second or third problem. Okay. So Henry's law constant for CO2 gas. Okay, CO2 gas in water is 1.67 into 10 power 8 Pascal. Okay, 10 power 8 Pascal at 298 Kelvin. Okay, calculate the quantity of CO2. Calculate the quantity of CO2 in 500 ml of soda in 500 ml of soda water packed with the pressure or under pressure 2.5 atmosphere of CO2 pressure at 298 Kelvin. So this is the question for you given in the last class as a homework. So students, here what they given? They given Henry's law constant Kh is equal to 1.67 into 10 to the power 8 Pascal. Okay. So again they given what? This one they given. Again they given what? This one. P is equal to 2.5 atmosphere. So this is better to convert this into Pascal. So that is 2.5 into 1 into 10 power 5 Pascal. This is actually 1.0135 is there, but if this is approximately 1 means we can take 1 into 10 raised to 5. Okay, so this is what pressure in Pascal. Both the inputs become same. What we are going to calculate? The quantity of CO2 in 500 ml of soda water. So first we have to check X of CO2. Okay, so using Henry's law, what is the formula? P is equal to Kh into X of CO2. This is pressure of CO2. Then you apply here. What you will get? This is the given value, students. So P of CO2 is 2.5 into 10 power 8. 10 power 5. That is equal to Kh means this one 1.67 into 10 power 8 into X of CO2. So then what we have? X of CO2 is equal to 2.5 into 10 power 5 divided by 1.67 into 10 power 8. Then we will get 1.5. Okay, approximately we will get 1.52 into 10 power minus 3, that is 0.00152. Okay, this is what X of CO2. Okay, students, what is the formula for this X of CO2? So the number of moles of CO2 is equal to mole fraction of CO2 is equal to number of moles of CO2 divided by number of moles of CO2 plus number of moles of H2O. As I told you, solute present in a very less quantity means this becomes what? X of CO2 is equal to N of CO2 by N of H2O. Okay, here they given what? In 500 ml of water they given. So by using 500 ml of water, we have to calculate number of moles of water. So here, as I calculated in the last class, 500 ml of water means 500 gram of water. This is an assumption. 500 ml of water means 500 gram of water. So here, so students, we know in 1 kg of water, number of moles is 55.5. Okay, in 500 gram means half kg. How much? If you multiply these two, you will get 50.55 divided by 2, that is 27.75. 27.75. You may easily calculate 1 kg 55.5 for half kg how much? 1000 gram 55.55 moles. For 500 gram how much? Like that. Okay. So this is what N of H2O is equal to 27.75 for 500 ml. Okay. Here we have X of CO2. Then after here, X of CO2 is equal to N of CO2 by N of H2O. X of CO2 how much? 0.00152, that is equal to N of CO2 divided by 27.75. Then you will get, students, approximately the value is equal to 0.042. This is moles. And now, once you got the number of moles, we have to check what? Quantity of CO2. So therefore, quantity of CO2 is equal to N of CO2 into molecular mass of CO2. Okay, N of CO2 is 0.042. Molecular mass is what? If you get 1.824 grams. This is the quantity of carbon dioxide. This is 1.848. So this is the quantity of our students. The CO2 which is packed with the pressure 2.58 atmosphere in 500 ml of soda water. So what it means, what it explains? So listen, here we given the Henry's law constant, pressure, and by using these two we can calculate mole fraction of CO2. If we got the mole fraction of CO2 by using the formula, students, here they given 500 ml means we can easily calculate the number of moles of water. So by comparing these two, we can easily solve this problem. Okay, if you have any doubt, you may ask it again. Okay, so listen, remember one thing, units must be in the same unit. Okay, here pressure is there or any other is there, and this constant, as I told you, this is directly proportional to what? The pressure means it obeys the formula of the pressure. Okay, so this is all about the SRS problem. Okay, we will go with the next one. That is so the next one is problem is that. Or that is the vapor pressure of chloroform. Vapor pressure of chloroform, that is CHCl3 and dichloroethane CH2Cl2 298 Kelvin or 200 mm of Hg, 200 mm of Hg and 415 mm of Hg, okay, respectively. What you have to calculate? First one, calculate vapor pressure of the solution. Calculate vapor pressure of the solution prepared by mixing. Prepared by mixing 25.5 gram of CHCl3 with 40 gram of CH2Cl2. 40 gram of CH2Cl2 at 298 Kelvin. So next, second one, mole fraction of each component. Mole fraction of each component in vapor phase. Okay, this is the question. What are given here? So listen, the vapor pressure of chloroform and dichloroethane is accumulated Kelvin of 200 and 450 mm of Hg respectively. Calculate vapor pressure of the solution prepared by mixing 25.5 gram of the CHCl3 with 40 gram of CH2Cl2. Next, mole fraction of each component in vapor phase. How we have to calculate? First, you write what is the given values here. Here the given values are right here, students. Given values are the given P1 value, that is how much? 200 mm Hg. P2 415 mm Hg. The given W1, that is 25.5 gram, and W2, that is 40 gram. What you have to calculate? Vapor pressure of the solution, that is P total, and also P is equal to vapor pressure, P at vapor phase. This you are going to calculate. Okay. So students, here what you are going to do is first, by using these values, calculate number of mole of CHCl3 and CH2Cl2 individually. The given CHCl3, CH2Cl2 formula there by using and weigh here. So the given mass divided by molecular mass gives what? Number of moles of the respective compounds. Okay, here moles of CH2, Cl2. Okay, so moles of CH2, Cl2 are molecular mass, right? Molecular mass of CH2, Cl2. Carbon is 12, hydrogen is 2, this is 71. You will get how much? 84. 35.5. 85 gram. Next, molecular mass of CH2, CH, Cl3. How much it is? CH is 12, hydrogen is 1, Cl3 means 71 plus 35.5 means 106.5. How much will be the answer, students? That is 119.5 gram. This is molecular mass of this CHCl3. This is the molecular mass of CH2CL3. Okay. So once you got that, here the molecular mass is there, here the given mass is there. Then you can easily calculate number of moles. Okay. So the total number of moles are N of CH2Cl2 is equal to how much? The given mass of CH2Cl2 W gram is 40 and here it is 85. 40 divided by 85 you get students 0.47 mole. Okay. Similarly, N of CHCl3 the given mass is 25.5 divided by molecular mass is 119.5, you will get how much? 0.213 mole. 0.213 mole. This is what N of CH2Cl2 and N of CHCl3. So these are mixing with each other. Then calculate X of CHCl3. What is the formula? N of CHCl3 divided by N of CHCl3 plus N of CH2Cl2. Correct? So N of CHCl3 is how much? This CHCl3 0.213 divided by, if you add both the values students you will get 0.683. Then you will get X of CHCl3 is equal to how many? Answer? So 0.688. Okay? So this is the answer. So CHCl3 right? 0.312. CHCl3 is 0.312. So students, you know this mole fraction we got means you can calculate the mole fraction of CH2Cl2 by using same equation, or you just this X of CHCl3 plus X of CH2Cl2 is equal to 1. We have the value here for CHCl3 0.312 plus X of CH2Cl2 is equal to 1. Then we want X of CH2Cl2 means it is equal to 1 minus 0.1312. We will get X of CH2Cl2 as 0.688. This is the answer. We got what? X of this and X of this. Okay. Then what we are going to calculate, students? Vapor pressure of the solution prepared by mixing of the solution. So here we have routes. So we have the formula P total is equal to P1 naught plus P2 naught minus P1 naught into X2. Correct? We have this formula here. Here X2 is what? That CHCl3. Because here what they given? Vapor pressure of the solution prepared by mixing 25.5 gram of CHCl3 with 40 gram of CH2Cl3. Which one present in minute? That is called as what? Solid. So option here we are going to take CHCl3 as X2. So here P1 we have correct 200 P2 we have 415. So X2 is what? That CH2Cl2 value. Okay. So students, we are going to apply here this 200 plus 415 minus 200 into X2 concentration is how much? 0.688. Okay, because here we have taken this one as x1, this one as x2. Here we got for CHCl3 we got this much, for CH2Cl2 we got this much. Graph is variated with the concentration, mole fraction of this solvent or a solute. Okay, which one is volatile or depends on that. So here what happens? 200 plus, so this is 215 into 88. Then you will get answer, students. 200 plus 147.9. Okay, you may approximately take 148. Then you will get 200 plus 1, that is 347.9. What it is? P total. So first one answer we got. The calculate vapor pressure of the solution prepared by mixing 25.5 gram of CH3 with 40 gram of CH2Cl2. This is the pressure of the solution we got after mixing those two solutes. Okay, what they have given first? They given the values of the pressures. Okay, pressures of the individual components or solute or solvent, whatever you may. Both are liquids, means this is a liquid solution, students. So the vapor phase of each component, the fraction of each component in vapor phase. I'll write the formula, then you can know. So next, by using this, so what we need number of particles first. So they didn't given directly the number of moles, they given different values of the solute particle. Here 200 gram is there, 25.5 gram is there, but the formula they given by using given mass by molecular mass, we can easily calculate number of moles. Once we calculate number of, once we got the mole fraction and we have pressure that can be applied to this formula, then we will get the pressure, total pressure of this. Okay, so students, formula for this is all for first one, first second one. Okay, so what they given? Mole fraction of each component in vapor phase. So in vapor phase, what is the formula means? P1 is equal to, okay, P1 is equal to Y1 into P total, and P2 is equal to Y2 into P total. So they are taken as what? The mole fraction as this. Now if mole fraction is multiplied by the total pressure, then we will get the pressure of the respective atom. So here we want what? Mole fractions in their vapor phase. So this is the formula. For second, this is the formula for the vapors of the liquid solution in vapor phase. Okay, the formula for the vapor pressure of the liquid solutions in vapor phase. So see directly, this is the formula. Pressure of one component is equal to mole fraction of one component into total pressure. How it comes? So listen, P total is equal to X into T is there. So vapor pressure decreases means it is inversely proportional, then it is multiplied. Okay, so this much you remember, students, that is enough. So we want what? Y1. Y1 means Y of CHCl3 and Y of CH2Cl2. So Y of CH2Cl2 we want means, sorry, CHCl3 we want means this become what? P total divided by pressure of CHCl3. What is P total here? 347 point. Sorry. This is what? P1 divided by P total. So P1 is how much? 200. Divided by P total is 347.9. So you will get The mole fraction of this at the vapor phase is, that is 62.4 mmHg. Similarly, for CH2Cl2 means P2 divided by P total. P2 is how much? 450 divided by 347.9. Then you will get the answer 0.18. Sorry students, first we are going to calculate the pressure of the individual vapor vessel. I hope you understood this, because I need more space means I will rub this students. This is first one. I will go with the second one now. That is the formula, actually correct formula, but before we are going to do that, we have to calculate the pressure individually. So that's why for second option, what we got here, to solve the second, the given value is P total is there, that is 347.9. Correct? Next, X of CH2Cl2 is there, that is 0.688. X of CHCl3 is there, that is 0.312. Okay? 0.213. This is what? The mole fraction of CHCl3, and this is the mole fraction of 312. This is mole fraction of CH2Cl4, mole fraction of CHCl3. This we need for the solution, sorry, to solve second question. Okay, mole fraction of each component in vapor phase. So students, as I told you, the vapor pressure of each component is equal to mole fraction. P of CH2Cl2 in vapor phase is equal to what? X mole fraction into P1 naught. P is equal to, you know the formula, in vapor phase, P is equal to, or P1 is equal to X into P1 naught, and P2 is equal to X2 into P2 naught. We have to calculate the pressure of CH2Cl2 and that CHCl3 in the vapor phase. Here, pressure of CH2Cl2 is equal to mole fraction of CH2Cl2 into 415. So we will get a 0.688 into 415. We will get 285.8 mmHg. Similarly, okay, P of CHCl3 is equal to X of CHCl3 into P2 now. So here mole fraction of CHCl3 is 0.312 into pressure is 200. Then we will get approximately 62.4 mmHg. Once we got the pressure of this and this, students, we can easily calculate the vapor pressure value. So as I told you, vapor pressure of CH2Cl2 is equal to mole fraction of 1 into P total. This is that one, this is 2. So mole fraction of CHCl3 is equal to Y1 into P total. We have P total here. We have pressure of CH2Cl2 and this one here. Then we can easily calculate Y1 and Y2. So student, Y1 means that is P of CHCl3 divided by P total. P of CHCl3 is 62.4 mmHg divided by P total is 347.9 mmHg. Okay, these two gets cancelled. You will get the answer approximately for CHCl3 0.18. 0.1. Similarly, for Y2, that is P of CH2Cl2 divided by P total, that is equal to how much? 285.5 mm Hg divided by total pressure is 347.9 mm Hg. So if you divide the students, you will get the answer 0.82. Okay, or if you don't know, if you got only this much students, you just minus this y1 plus y2 is equal to 1. So y2 you want means y minus y1, so that is equal to 1 minus 0.18, you get 0.82. You may do this or you may do this, you get the same answer. This is the vapor pressure of each component in and a mole fraction of each component in vapor phase. This is in liquid phase. Okay, so this is in vapor phase. I hope you understood, students. So this is the from equation or from these given data we calculated these three which is required for first. Okay, by using what we calculated in the first session or a first question or a first answer. So by using those data we can calculate the second one, and this is very important for 3 marks. Okay, this is very important for 3 marks. This is 1 and this is 2. Again they used to tell the same question, students. Another one is there. What it says here, which one is more volatile? Okay, the pressure of which is more here? Here 200 mm they given, here 415 mm they given means. So which one has the greater pressure, that is highly volatile, means CH2Cl2 is highly volatile. So if we consider mole fraction also listen, here 0.12 is there, here 0.82 is there. So here the concentration is more, so number of vapors are evaluated and evolved is also more here because it is highly volatile. By comparing the pressure, by comparing the mole fraction, we can easily check which of the following element is highly volatile. If in this question they may ask students, if they ask only to calculate the given data and they used to calculate the second one, means this is for 2 marks. They might ask which one is highly volatile in this compound. In this, CaCl3 is less, having less pressure, dichloroethane has greater pressure means, so one which has a high pressure is a highly volatile compound. Okay, that is the key point, remember that. Okay, so the next one is last problem. Same based on this only, vapor pressure of the liquids. Next problem, students. The vapor pressure of pure liquids A and B open. The vapor pressure of pure liquids A and B are 400 and 700 mm Hg respectively at 350 Kelvin. Okay, find out the composition of liquid mixture. Find out the composition of liquid mixture if the total vapor pressure, if the total vapor pressure of the solution is 600 mmHg. Also find the composition of the vapor phase. Also find composition in vapor phase. So students, here what is the given the values of PA naught, the given values. Liquid A, the given PA naught is there, PV naught is there. We have to calculate X. Okay, from using this and P total they given, we have to calculate X. Okay, so here P and naught is there. How much? 400 mmHg. Correct. Next, PV naught is there. 700 mmHg. P total is 600 mmHg. We are going to calculate for this X. Okay. So what is the formula we have here? We know P total is equal to PA naught P1 naught plus PB naught minus PA naught into X2. Correct? This is the formula we have. So by applying the value, students, P total is 600, PA naught is 400, PB is 700 minus 400 into X2. So this is 600 is equal to 400 plus 300 X2. So we will get 600 minus 400 is equal to 300 X2. So we will get 200 is equal to X2. So X2 is equal to 200 divided by 300. 2 by 3 means the value is, sorry, this is not 400, this is 450. Sorry, this one is 450 here. Okay. How much we get? So 600 is equal to 450 plus 250 extra. 600 minus 450 is equal to 250 extra. So here we will get how much, students? This one is, because they are given, this one is PV here, PA here, and apply the formula here. P total is equal to PA plus PB. Then we will get P total is equal to PA naught into XA plus PB naught into XB. So we want what? P total is equal to PA naught minus PB naught XA plus PB naught. This one is correct? Okay, correct. This is 450 minus 700 into XA plus PB is 700. Then this one is 600. So students, then we will get 600 minus 700. If you get this thing, we will get minus 250 xn. So here this is minus 100, that is equal to minus 250 xn. Then xn we will get minus 100 divided by minus 250. So 1 divided by 25 means we will get 0.4. So x2 value we will get here, students, that is 0.4. So why I am taking this one as a solute means, listen, here it has a 450, here it is a 700. So this one is highly volatile, this one is less volatile. So as I told you, the concentration or the mole fraction of the vapor pressure increasing means that depends upon what? Mole fraction of the second component. So that's why I given here. This is very big. This. Okay, this is the vapor pressure of the component. So this is 0.4. So if this is 0.4 means XA plus XB is equal to 1. So XB is equal to 1 minus 0.4. So XB is equal to 0.6. So we have pressures and we have this concentration terms, then we can easily calculate PA and PB. So PA is 450 into XA means 0.4 and PB means 700 into 0.6. How much we will get? So 450 into 0.4 means we will get 110 and here we will get 420 and here also So once we got PA and PB, students, we can calculate PA is equal to YA of P total. Then we want YA means that is PA divided by P total. Okay. So what is the PA value here? PA means that is 110 divided by, this is 180 or 150. So 180 divided by P total is 600. Correct? Then you will get answer. So YA is equal to how much? 0.30. Then YB is equal to 1 minus YA. Then YB is equal to 1 minus 0.3, that is 0.7. This is the composition of the solvents in the vapor phase, or composition in the vapor phase, and the mole fraction in the vapor phase. So students, as I told you, they given the vapor pressure of the two different liquids, that is 450 and 720. So total pressure they given is here. So we know that P total is equal to PA plus PB. So P total is equal to what? PA XA plus PB not XB. So we are going to calculate any one of the mole fraction here, either A or B. Once we got A, we will get B. Once we got B, we will get A. So you may take whatever it may be, students. If I take first one like PA minus PB naught into XA plus PB naught, right? You may take PB naught minus PA naught into XB plus PB naught. Okay, any one molar concentration should present here. So then what happens? It will give the mole fraction 0.4. Here for simplifying the calculation, I take on this way, students, because we will easily calculate 1 by 25 means it is 0.4 only. But if you have calculators in the examination means you may apply whatever the formula you want. Okay, either you take this or XB you may take. Okay, once we got the molar concentration of this, so listen, as I told you before, I wrote 1 by 3 we got means we will get approximately 0.6, that is molar concentration of B. If XB is 0.6 means we will get XA as 0.4. That only I did here. So once we got the mole fractions, then we can calculate pressure of the each component by multiplying with the standard pressures. Okay, then we will get pressure of the component, individual components. So once we got the individual component pressures in the solution, we can easily calculate the composition of the components and components A and B in the vapor phase. Here which one is highly volatile? This one. B is highly volatile because it has 700 mm of pressure. Okay. So this is a Lopat problem. This is also important for 3 marks. Okay. You may check the students. If you have any doubt, you may ask in the group. Thank you.